So last day we have discussed about the strategy of using pipeline for various instruction in a situation, and we have seen the concept of stalling, and which is basically reason of pipeline hazard. So today we will start discussing about the pipeline hazard. So our topic for today is pipeline hazard. And so first we have to define that what an hazard is, right? So let's define it first. We can say that it is a situation that prevents the next instruction in the instruction stream from executing during its designated clock cycle. What does it mean? It means over here you see that although third instruction decode was completed at fourth clock cycle and the execution of third instruction can be easily started, but it is delayed till 7 clock cycle because the previous instruction was too longer. Although here the reason is different because we have considered different length of different length with respect to timing for different type of instructions. However, if the similar type of situation arises because of unavailability of something within the instruction, then it arises the hazard. Now I can say that any condition, that means any condition that causes stall in the pipeline actually pipeline operation is called pipeline hazard. I'm sorry. Now you see this word stall already you have found in my previous lecture. Over here you see if you somehow cannot correlate this particular keyword, so you can go through my previous lecture video and you can find that. Anyway, so now naturally question will come that absence of what are the different situation for which this type of stall happens. With respect to different situation, this hazard, the cause of the hazard actually can be defined in mainly three ways. So hazard, a pipeline hazard is defined mainly in three parts. Sorry. One is called data hazard, then control hazard, sorry, and third one is called structural hazard. So, I mean, what are the different reason of this data hazard and different type of hazard actually? The data hazard is said that this is actually reason, or in other words, this is what you can say, unavailability of data. In how what does unavailability of data mean? We will realize it very soon. Here it is, you can say that unavailability, let's write it, of instruction. Again question comes that what does unavailability of instruction mean? One thing is sure that unavailability of data means data is not available, or unavailability of instruction means instruction is not available. Now what is the what does it mean that we will go through one by one? Just I'm writing this as a point so that you can remember their difference. Here it is unavailability of hardware. Okay. Now let's see. I mean, if I investigate these three different hazards one by one a little bit, what does this data hazard mean? I mean, suppose that if we have a situation, suppose that I have two instructions. Okay, I have two instructions. I1, it mean the instruction is something like add R1, R2 and R3. What does it mean? It means R3 equal to R1 plus R2. Suppose, although this type of instruction is not really practical with respect to various processors, the instruction is little bit different. We will see this different type of instruction in other classes. But just for time being, assume that we have in some processor we have an instruction something like this whose meaning is the R1 and R2 will be added and will be placed in the R3, the result. And suppose I have one more instruction I2 which is saying that, say, multiplied, say, R3 uh, comma R4 comma R5. And what does it mean? Naturally, in a similar way, I can say that it can be meaning something like R5 equal to R3 plus R into R4. Okay. So now see, if I pass these two instruction in a pipelining, obviously the pipelining through the pipelining I have sent this to instruction mean the instruction will be executed, I mean will run in parallel, right? So let's see what will happen. If we just draw, you see, if we consider this I1 instruction, this I1 will be fetched first, and then when the I1 will be start decoded, I mean let's do one thing, let's try to realize it from the pipelining point of view, not with respect in this way. Let's draw a situation of the pipelining. It will obviously look something like fetch. If we consider that I have four stages: execute and write back. These are the different time instant. Okay, as we have already drawn different cases, in a similar way we are drawing this situation. So time slice 1, 2, clock cycle 3, clock cycle 4, clock cycle 5, clock cycle 6, and so on. So now we know that obviously instruction 1 will be fetched first, so fetch 1. And if I forget about the difference between the execution time between add and multiplication instruction for time being, if I consider that these two instructions take same amount of time, then also let's see what will happen. After fetching instruction 1, decoding of instruction 1 will start, and similarly fetch of instruction 2 will start. So it's okay. Now we are considering that add and multiplication both is taking only one clock cycle to execute. Okay. So after second instruction, after the first instruction decoding, execution of the instruction 1 will start, and at the same time decoding of instruction 2 will start. So still this is possible. Now you see, if I assume that when the write back operation of instruction 1 is going on, and at the same time if you let execute the instruction 2 over here, then whatever will be computed on fourth clock cycle for instruction 2 is going to produce a wrong result. Why I'm saying this one? The reason is that the purpose of this write back operation to write the result in the respective location. That means one thing I can say that until and unless this write back operation completes, this R3 will not be updated with the new value. And before completion of the write back operation, that means R3 contain already the old value. That means when the write back operation of instruction 1 is running, and at the same time if you execute the instruction 2 in execution stage, that means this instruction 2 will take some old value of R3, and as a result it will produce some wrong result. Because if we consider a simple C program which is representing these two instructions, something like, for example, A equal to B plus C, and then say if I write D equal to E plus E into A, what you expect? If I say that, say B is equal to 1, C is equal to 2, and E is equal to 3, then your result for D will be what? B plus C, that means 1 plus 2 equal to 3, and that 3 will be multiplied with this 3 equal to 9. So D equal to 9 is the correct answer, because although I am sending this I1 and I2 in the pipelining, it should not violate the order of the execution in anyhow. That means although they are executed in parallel, the dependency of these two instructions should be maintained. And if somehow I ignore this dependency, ultimately I will get wrong result, which is going to some wrong output as a whole in the program. So that means when the write back operation is running, you cannot place E2 over here. Although the execution of in previous instruction was completed, still you cannot continue with the execution of second instruction. The execution of second instruction can start from here only, because after fourth clock cycle the write back operation is completed. So that means the A got the new value. Now you can use this A over here to get the correct value of D in the fifth clock cycle, and then you can continue for writing back the second instruction. So if you see, we have something what we call, this is what? This is just, we have seen in a previous case, we call it bubble, or also we can say it's basically stalls, and that is why we say that we have a data hazard. And what does this unavailability of data mean? It means that because of this exact actual value of A is not available at this time, that's why you cannot continue with executing E2. And that means here the unavailability of the data A. So this is what actually data hazard is. Now in case of instruction hazard, in case of control hazard, what I have written, that unavailability of instruction. Now what does it mean? It means that, you see, if you think about a function call in a program, what happens when we write let's take a very simple situation. Say I'm writing a main program, and there is some code written, and here I have called a function fun, f1, suppose, and after this I have some other instruction present in the main program, and it ends. And now let's define this f1 function. So suppose void f1, something like this. Okay, and within this f1 function, if I define, suppose I have many other instructions, and then I have called f2 another function, and then I have some more instructions and I have stopped. And then I have one more. I mean, obviously I have to define this f2. So let's define f2 again. So void f2, and there is some instruction, there is no more calling, and it ends. So suppose situation is something like this. We have a main program, a f1 program, an f1 function and f2 function. Now you see the program that we have written in high level language. When the program is executed by a computer, what happened? This entire program should be loaded in the primary memory, that is RAM. So now if we consider the situation of RAM in this situation, I mean in this case, I mean let's draw a memory. Suppose this is your RAM. Okay, we all know that memory is basically array of I mean RAM is basically array of memory locations. This is your RAM. Okay, and you have lot of memory locations present over here, right? And there is some many locations are present, something like this, and there is now what happened, this program is not directly transferred in the RAM. What happened, the corresponding machine level instruction is stored in this memory. Now I'm ignoring all these different instruction part, only I'm concentrating on this line. I mean the line when the function call is happening, there is a specific instruction call, then an address we have to put, we have to write an address of what? Address of the first location of the other function which is called. That means you can say that you can have instruction 1, instruction 2, which is representing these instructions, and then we have a call. Call what? Call to the address. So if I for just for situation, if I consider this is address 100, this is 100, 101, this is 102, 103, 104, and then it's say 500, 501, 502, 503, 504, and then 700, 701, 702. I'm just arbitrarily writing some memory location address in decimal form. Okay, just for time being. Assume that this, I mean, why I have drawn in this way, because I'm assuming that the main function is present over here. This particular part contains the function f1, and this particular part contains the function f2. Okay, so f1 started on address 500. That's why here I will write call 500. Similarly, I have some instruction over here again for in f1 function, and there another call, because it will call f2 function right over here. That means f2 started on address 700, so it will be call 700. So what does it mean? You know, this particular call instruction is a valid instruction in 8085 microprocessor. Okay, just what we have discussed as a uh, mm, I mean as a prototype at the first class of my lecture. Now what does call 500 mean? When this call 500 instruction is decoded within the system, within the processor, after decoding, the processor understand that now I have to jump where, in this 500 address. Now in this situation, in this time, if you look into the content of program counter, we know that program counter holds address of next instruction. That means when the instruction of 102 address is executing, program counter contain address of 100. I mean, program counter contain this 103, because program counter is expecting obviously the next address. The instruction will be now taken from the next address, that is 103. So in this situation, that means when this call instruction is actually decoded, at that time already the next instruction, say I3 of the main function, is entered in the pipeline and started fetching. With respect to this situation, if I can easily understand that if I consider that this I2 instruction is the call instruction and I1 instruction is the previous instruction, just we have seen over here. Okay, so that means when I2 is decoded, I2 has started fetching. When I1 has decoded, I2 has started fetching. Suppose this is my call instruction for timing assume, and this is the another instruction next to call. Okay, so when this call instruction has started decoding, this I2 has started fetching, and then after completion of the decode, the machine realizes that after the execution I2, I should execute the instruction of 500 address, that is this I1. But unfortunately, this I2 has already entered in the pipeline. That means as soon as the processor will realize that some wrong instruction has been entered in the pipelining because of late understanding about the next instruction address, so only job left, that is somehow the pipeline, the processor has to flush out whatever already pre-fetched instruction present in the pipe. That means somehow one thing is clear, that after this call instruction execution, the next instruction that was really should be executed, that is this one, is not possible to execute exactly in the next clock cycle. There will be some time wasted for flushing out the unwanted instructions that is already entered in the pipeline. That means what I can say, that at that point of time, the instruction that I should require, that is this I1 instruction of the F1 function, is not available, and that actually causes what we call control hazard. That's why I have written unavailability of instruction. Now if we come to this point, structural hazard, this is about the unavailability of hardware. It's not possible to show you the situation with some diagram, but just assume in a situation that there are two instructions in a pipelining which is trying to access the same hardware at the same point of time. So naturally there will be some resource conflict. So naturally, unavailability of hardware, I can also say it is something like, you can say, a resource conflict, right? And for this, the hazard that happened, the stall that happened, is called structural hazard. So these are the three major category of hazard we have in our in a pipeline condition, pipeline situation. Now we will go through the different hazard in more detail, and we will start with the data hazard.